But welcome to the very first Scicomm Monday. We're excited about it. We're gonna make sure that we get this shared out to everyone real quick. Hi there, everybody. Glad you could log in. We're gonna get this, like I said, put out on all the formats here real quick, and then we'll bring Dr. Karen Joyce in. Great. Should be good to go. So, thank you all for logging in. We have our special guest, Dr. Karen Joyce, here with us for our first one. So, and then, so any questions you have or anything, feel free to go ahead and send them through on the Periscope, because we want this to be as engaging as possible. So we'll get us logged up in here for everyone. So I guess my first question that I'm going to start off with, and if you guys, like I said, have any questions, feel free to send them in, and we'll make sure that Karen gets to see those and ask them. But maybe just give us a little background of your history academically, and like how did you get to where you are now? So.
Yeah, it's interesting because I guess I've had a bit of a non-traditional career. So I went through and studied at University of Queensland, and then when I finished my PhD, I decided to check out of the university and academic life and joined the army. So I spent a couple of years as an engineer in the army, learning to build bridges and blow them up. And then I moved to New Zealand for a couple of years. My husband's a Kiwi, so went over there and went back to doing some more remote sensing work, looking at natural hazards and also recreation opportunities across New Zealand. So quite a variety of things before I then returned to academia and more remote sensing teaching, and research around different types of environments and how we can map and monitor them with satellites primarily.
Is it really common for people to go into the Army before they go into furthering their careers in Australia, or is that something that's more on the uncommon side of things?
No, that was very random. Okay. Well, I mean, not random for me, but I guess random for those around me that saw me make that decision. For me, I did it because I felt like I'd spent so long in the school system. I went straight through, primary school, high school, straight through to PhD without a break. And I just felt like I needed some different experiences, I guess. I mean, I'd worked in jobs whilst I was studying, but I wanted to do something that was just really quite different and out of the box.
Like, how do you think that, helped you? Was it just, nice having the break, or were there other experiences in that helped you in your career now? Like, not just, doing research, but maybe, additional skills that you got out of it that you feel were helpful?
Yeah, definitely. Well, it was definitely a sidestep career-wise, and, maybe didn't fast-track me through my academic career as fast as I could have been if I had stayed in academia the whole way. I got a lot of experiences out of my military work that I just wouldn't have had anywhere else. As soon as I started, I was in charge of a multi-million-dollar project, had a number of staff that I had to manage as well. At any one time, I could have up to 40 soldiers under my command. And to sort of get to that level of leadership and management in a civilian situation actually takes quite a while to get there. And often, particularly in a university situation, when you're required to step up into management roles, you get no training whatsoever, right, which is very different to the way you're treated in the military. So for every step you go through your career, you receive training that's appropriate for that. So it's not just skills-based, but it is very personal management as well. So those sorts of things I definitely take with me. There's a lot of leadership skills that you get through working in the army, and of course heaps of networks as well. So I know people all around the place that I still catch up with, and that's useful in my civilian life as well.
Yeah, I think that management thing is probably the thing I'm really gaining from that, from what you're talking about, because I hear all the time with professors and grad students that their skill base in management, how do you manage a lab, how do you manage the students in the lab, they don't get the training to do that. You just have to do it on the fly. But here you actually had training in how to do that, on a larger scale. And I think that you feel that that's helped you now as you're a professor having to manage a lab.
Yeah, it absolutely does. I mean, by no means would I say I'm perfect at it or even very good, but at least I have some skills to call upon to start to continue learning as well. And I mean, that's something I am continuing to do, to try and figure out how you manage better the whole time, because that's ultimately the way we're going to get better results out of our staff and out of the work that we do. And it's not easy, but I do feel like I have a bit of a head start in that regard.
So talk to us, real quick. I'm going to remind everyone we're currently live on Periscope with Dr. Karen Joyce. She's in Australia right now, so this is our first test here with this dual broadcast Periscope that we're trying. So if you have any questions for her or for myself, feel free to start sending those in via Periscope in the chat there, and we'll try to get to as many questions as possible. So tell us a little bit about your research. You like using drones or UAVs or UAS, however you want to call it regionally. Do you guys mostly call them drones in Australia? I know that there's been a big pushback in the U.S. of calling them drones because of the negative connotations with the military. So a lot of times we call them the unmanned aerial vehicles or unmanned aerial systems around here. But I find a lot of researchers are still calling them drones. So what's your preference, and maybe regionally down there too? What's the preference?
It's an interesting one. So officially now in Australia we're supposed to be calling them RPAS, for remotely piloted aircraft systems. And the reason for that change is twofold, I guess. First of all, to take out the unmanned portion, let's make it a little gender neutral. And also that the Civil Aviation Safety Authority, which is the equivalent of your FAA, wanted to emphasise that there's still people involved in it. So it's not like you've got a craft up there and it's totally autonomous, and in fact you have to maintain control of it. So by saying it's remotely piloted, that kept the pilot in the terminology there. So yeah, RPAS is the official word in Australia. I stay away from UAV being unmanned airborne vehicle because I'm less interested in the craft itself and more in the sensors. So I like to use the word system if I'm going to use unmanned airborne system. But just dealing with people in general, the public calls them drones, and I actually thought that for a while. I did want to keep it being UAS or RPAS, but then gave up on that and just figured, well, everybody else calls them drones, let's just call it drones, and at least we're speaking a common language.
Yeah, I feel like that's the big thing, is when I'm trying to explain to people what it is, if I say UAS, and even if I say unmanned aerial system, they still don't quite get what that is. And as soon as I say drone, they're like, oh, yeah. So, we had a question.
Yeah,
oh, go ahead, sorry.
It's just like... it's like saying remote sensing and you get a glazed look, and then you say, like Google Earth, and people understand what that is. So
exactly.
It's just about talking the language that people understand and educating along the way, and it's all good.
Right. So we had a question come in from One Planet Woman, I believe is what it was, if I recall the tag properly. What is your favorite species to study?
Hello, Dr. Kath Ball. Nice to see you here. So I'm not a huge animal person. I work more so on plants and landscapes in general. And I guess you could say that corals are an animal, so I'd probably have to say that they would be my favorite animal to study. But as a whole, I don't consider myself someone who uses drones to study animals per se.
Yeah, I noticed in one of your pictures that you had loaded up several months ago that you were actually we were trying to count the sharks in some of your imagery. So do you think like you might be able to move over to that where you're doing more large animals like that to be able to monitor them with the remote pilot systems? Or are you think going to stay still in the corals?
I do have some amazing and completely lucky footage. It was never intended to capture sharks and rays and turtles, but they're all in images that I've captured over the reef. At the moment in Australia, you still require a permit to observe any cetaceans, and so I'm actually not allowed to go out and actively try to survey or monitor them. But I definitely think that down the line, this is going to be a good way of people looking at animal behaviour, and it is a lot less intrusive than many other techniques that people use for animal monitoring. And so you see in the photo that you've got up on the screen there's a number of sharks you can see sort of towards the upper middle area. In that particular one, I can count at least 3, but I think there's a couple more there as well. I think there's a couple of rays somewhere in that image as well, but I can't quite see
I wasn't able to quite get the whole image on the screen. I know there was a couple more sharks at the bottom of it, but it was fun to be able to try to pick out what it was that we were able to see with it. And so not only are you able to do landscaping and see where the corals are, but to see animals and stuff. Like for me, I'm interested in remote sensing to see behaviors and things like that, not just where is that particular thing in the landscape. So.
Yeah, well, I guess my expertise is in the technology, and I work with scientists from a number of different disciplines to help them, basically. So, if someone comes to me and says they've got a particular project that they want to look at, a good example was a couple of days ago, someone wants to look at holothurians or sea cucumbers, and, I can provide that expertise in there, but I wouldn't sort of dream up the sea cucumber project myself.
So you could actually see those from the air as you're flying over and be able to pick those out in your imagery?
Yeah. So I've got some really amazing imagery from Heron Island last year, so in the southern Great Barrier Reef. And yeah, you can see individual sea cucumbers, sea stars, all sorts of stuff. It was the conditions were amazing, and it was I think the flight was at about 60 meters height, so a really, really fine resolution, and yeah, you can count the individual critters.
Like, how big do those sea cucumbers get? Like, so when we're looking at a picture that you put up there, like, what's the scale that they're at?
So they range in size. I guess I don't know a huge amount about them, but from the ones that I've experienced when I've been out on the reef diving and snorkeling, I guess the smaller ones that I see would probably be about the size of your hand.
Okay.
But sort of more sausage-like, I guess, big fat sausage. And then all the way through to the ones that are more like a loaf of bread, so much larger ones.
So really, you're picking out animals that are quite tiny. You're thinking of, when you look at Google Earth, you're usually seeing those big images, and it's not quite that super fine resolution, but you're actually able to get even better resolution than what you can on Google Earth. Because I know with my mute swan work, if I look at Google Earth, sometimes I can actually pick out where those swans, but those are really large birds, and they're really white, so they stick out really well on the imagery. But you're talking about tiny little things underneath the water, that's only the size of a loaf of bread. That's pretty impressive, that kind of imagery.
Yeah, it's much better than what you'll see on Google Earth, probably by a factor of about 10, at least, depending on the altitude that we fly at. So, I guess the trade-off is, if I want to cover a large area, I fly higher, and our legal limit in Australia is 400 feet altitude. And if I want to get more detail, then I fly lower. And over water, I'm sort of comfortable with flying sort of at about the 10 to 20 meter level, or 30 to 50 feet or so above the water. And at that level, you can just about count sand grains.
Wow.
Not quite, but close to.
So, like, are you getting about to like 1 or 2 centimeters of resolution about that, or?
Yeah. So again, so it depends on the system that I use. But roughly at around about 60 meters altitude, it's a 1 centimeter resolution, or 0.8 actually. So yeah, really, really fine detail.
Nice. So you were talking earlier about some of the sensors you use. So for those people out there that just think of drones as taking just plain old pictures like you would get with your regular camera, just strapping it to a drone, do you want to explain a little bit more about the different sensors that you use and, kind of educate us all about the different names and what they do?
Yeah, so I fly a number of different drones that are each kitted out with different types of cameras, and that's sort of dependent on the job that I have at hand. So my most basic is I can fly a small drone with a GoPro attached, or I guess a lot of people are familiar with the Phantom drones, those white ones that you see quite commonly around, and you can buy from, I don't know, probably your local Best Buy or Harvey Norman here in Australia. So they've got just really small cameras on them. But if I'm doing a more advanced mapping job, then I'll fly with a digital SLR attached, just to get higher resolution. So with a 36 megapixel digital SLR that I can fly with, that gives incredible detail and beautiful data. So they're just sort of, I guess, the basic cameras, which everyone's familiar with in terms of just taking a photo that is red, green, and blue, that it looks the same color as what our eyes see. I then also use a thermal camera, so that's one that measures temperature. And the idea behind this one is that we wanted to look at changes in water temperature with the idea of maybe seeing how that affects coral health. And then the other sensors that we fly with are what we call hyperspectral. And basically what this means is that it takes all the light that we can see with our own eyes, plus some more light that we can't see, so this is near infrared light, and is able to make measurements across all of those different types of light. And that's really important because that tells us a number of different things that we can't see with our own eyes, and it enables us to make measurements of different things in the environment, like identifying different types of plants or corals or seagrass, and also helps us identify how healthy those plants are as well. So a range of different camera types and sensors that we fly with. It's really job specific in terms of which one that you choose to fly at the time.
So the light bouncing off of the say the corals, for instance, if you're looking at a particular wavelength, you're able to pick out the different corals then just by the wavelength that's bouncing off of them, rather than just like that's outside of our visual sensor, like our human ability to see.
It's not quite as simple as that. It's theoretically, everything has its own signature and looks unique in different wavelengths of light. But in reality, it's a natural system, and there's a lot of natural variability. So we know that there are some things that are unique to different features, and we use those to sort of help us identify, but it's sort of not to the level that you can pick out coral species or anything like that. But yes, to pick out the difference between, say, coral and algae and sand.
So you think maybe it's just having to create a database of the different wavelengths that they have that might, be maybe some of the next steps that you might do, and then once you get that database, then you can use that to be able to identify which corals are out there.
Yeah, essentially that's what we started doing that type of work about nearly 20 years ago now, I guess. Sort of developing that database of how different features reflect and absorb light in different wavelengths. And yeah, in a perfect world, you'd use that database to look at the images that you get and say, okay, find me anything that looks like this. But it is a little bit more challenging than that. And yeah, it doesn't quite work out as perfectly as we'd like to, but theoretically that's correct.
So maybe down the line, hopefully, as like the sensors become more fine-tuned, the technology improves, maybe that's something that 10 years, maybe 20 years down the road might be able to happen, you think? Or
I think it's a bit more than that, and I guess the reality is that we don't rely purely on the color of things to understand what different features are.
Mm-hmm.
So, for example, when we look at a white table that might be the same color as a white wall, we know that those two features are very different from each other despite them having the same color.
Right. And
so all cameras do is measure the color of something. But what our brain does is to look at those features and understand different things about them in terms of how they're spatially arranged, how they're in context with something else, whether or not they have a shadow, are there different textures, all sorts of different cues that our brain uses to make a decision around what a different feature is. And so that's the basis of old school aerial photo interpretation, to figure out what all those different cues are manually in your head.
Right.
And now what we try and do is to train a computer to pick up those same sorts of things. So it's not just relying on colour, whether it's the colour that we see or the colour that the sensors can see, but it's everything that's around that as well.
So, I mean, it might be something just as simple as, is it moving, or does it have a shape of something else, and you can identify what it is. You don't necessarily need the color. The color helps. It adds to that whole, the puzzle to make that one thing, so you know what it is and what it's doing.
Yeah, absolutely. So some things have very distinctive shapes or sizes, textures, mm-hmm. or they're always associated with something else. And we use a combination of all of those things to get the computer to name what that feature is for mapping purposes.
So just to remind everyone out there, we're talking to Dr. Karen Joyce from James Cook University down in Australia, live on Periscope. So if you have any questions for her about remote sensing, Great Barrier Reef, what it is to be a scientist, feel free to send those questions in. So you talked a little bit earlier about how you don't like the term unmanned aerial vehicle, and I know that you've started the initiative, the She Flies program. You helped co-found that. So can you tell us a little bit about what She Flies is, and what your goals are with that?
Sorry, I just missed that last bit. We had a bus that drove past the house.
Yeah, I could hear something going by. Talk to us about She Flies. So
my colleague Catherine Ball and I started She Flies late last year, I guess. So we started talking about the idea of trying to increase the number of females that we have flying drones. So we know in Australia, and it's probably quite similar in the States as well, that there's a really small proportion of women that are registered as drone pilots. And so we started to reach out to other women in Australia that we knew who were already flying. And our initial group that we sort of connected with via Facebook was 16 people. And we know that there's much larger forums, but they're filled with guys. And not that there's anything wrong with that, but we just wanted to see if there was anything that we could do to balance the equation there. And so we came up with this concept of She Flies, which is it's larger than drones. It's really more about encouraging girls and women to engage in science, technology, engineering, and maths, but using drones as the platform for doing that. So we know that we know that people do really enjoy flying drones and getting their hands on the controls and seeing how they all work. And so what our programs are designed to do is to really encourage girls to do this, but to take them out of the normal situation where they're placed in a classroom, for example, if you're in a school environment with boys. And generally boys will jump in and want to play with something immediately, whereas girls like to sit back and assess the situation a little bit more. So we thought if we separated the boys from the girls, we could provide something that works for both genders. So we also work with boys, but we're initially targeting girls. And we think that we needed to provide something that separated that and allowed for girls to learn in the way that they need to learn through experimental learning, without feeling pushed or hurried by the guys to reach for the remote control. And so, yeah, we've got a number of programs up and running for 2017, and we've been really fortunate to get both state and federal funding to support this. And we're actually running our first drone day with a local high school next Friday, where we'll put 60 young girls through the program. So it's really quite exciting to kickstart the year with that. It'll be lots of fun.
Wow. So, like, I may have missed it, but what age range are you shooting for when it comes to your She Flies program? Are you doing, all age ranges from, I don't know if you guys call it elementary school in Australia, but, anywhere from, 5 to 6 year olds on up, or are you trying to shoot more for those, older kids, or just anyone who's interested, you're wanting to get involved?
Yeah, so we've got a bit of a range of curriculum, I guess, in terms of the age group that we target. So we'll work firstly with corporates, so doing women's lunches or breakfasts, and so obviously the level at which we pitch the training there is quite different to something that we do with school kids. So that can be done sort of as a team building type exercise with corporate organisations, but also as more of a professional development for learning how to use drones to fly agriculture or anything like that. So that's one level. That's sort of at the more advanced and older or more mature person age. And then we also have the high school programs, and that's sort of our main thing at the moment is grades 7 through to 12. So that's ages 12 through 18, I guess. But we also work with schools to do what it is that they want. So we do have a number of primary schools that are interested in having something that's a little modified for kids of that age. So, for example, I will work with the primary or elementary schools and can work with the really young kids, so the 5 or 6 year olds, but won't fly with them. So we'll use the drones that just go on the ground, and so they start to get used to how to use a remote control, and they can still code them, but we just don't put them in the air, so just reduce that element of risk, I guess, with the kids that are that young.
Just get them at least exposed to it and help show them, hey, this is something really cool and you can do this. And I think for me, that's, at least when I deal with my niece and nephew, a lot of it is just getting them that exposure to it and to see that, hey, this is a possibility of things that you can go and do. And then they get excited about it and want to keep up with doing it. So.
Yeah, absolutely. And it's important for kids to see other kids doing things. So just a second, this is my kid. He's telling me I've got 3 minutes left.
No, it's 7:30.
Oh, it's 7:30, so he's been waiting for the 7:30 mark. So this is my son. Do you want to come here? Do you want to introduce yourself?
I'm Hamish.
Is that nice and loud? What's your name?
Hamish.
And do you like flying drones? What do you do with drones?
Code them on Tinker.
Yep.
Nice.
You drive them.
Yep. So Hamish says that he codes the drones on Tinker, which is a free app that he can use.
Wow.
And I've been teaching him how to code them to fly and do flips and all that sort of stuff. And how old are you, Hamish?
5 and a half.
Yeah.
Wow.
So Hamish is in grade 1 at school.
Yeah.
And he's 5 and a half, and basically he shows that if a kid of this age can learn to fly and code drones, that anyone can. Everybody.
Oh. Nice. That's awesome. So I'll have to get my 6-year-old niece to start doing that. So
Yeah.
Well, we'll let your mom go here in just a moment. So if anyone's interested in the She Flies program, how do they log on to find out more information about it?
Yeah, so a couple of different ways. We do have a website, which is sheflies.com.au, but also on Facebook, Twitter, and Instagram under She Flies AU. So you can find us there. We're quite active on Facebook and Twitter, but also through our website you can sign up to our newsletter to stay in touch. And for school teachers and parents, we also have a free ebook that you can download at the moment as well. And that gives a lot of information around getting drones into your schools and how do you support kids to learn with them as well.
Awesome, great. Well, we'll let you go because I promised to only keep you to about 7:30 and we're running a little bit over. So if anyone's got any questions for Dr. Karen Joyce afterwards, feel free to contact her at Karen Joyce 2. What is it? It's actually KE Joyce 2 or under the She Flies handle as well, I guess, are the best ways to get a hold of you if people have further questions afterwards. And then if you need
absolutely.
And then if you need to get a hold of me, feel free to contact me at wildlifebiogal.com. And if you have questions, I can always pass them on to Karen, or you can contact her herself. And just a plug for next week, we'll be talking to Dr. Cameron Webb from Sydney University with his work with mosquitoes. He's known as at Mozzie Bites on Twitter. So tune in for some more Aussie fun on Scicomm Monday. And until then, we'll see you guys all next week. So if you have any questions, comments, or anything, feel free to send us in, because like we said, we're just getting this started, and so any and all feedback is much appreciated. So until next Monday, you guys have a great week.